In question 5, they tell us in a normal distribution, we know that 68% of the scores fall between 72 and 86. That's this area right here. This is where 68% of the data is. And they're telling us that they lie between 72 and 86, and the mean is 79. So this middle peak is going to be 79, and one standard deviation below that would be a 72, and one above it would be 86, since those were the values that we knew that it was centered around. And they're asking, what is the standard deviation? If you look, there's a gap of 7 between each of these. 72 plus 7 would get you 79, and 79 plus 7 will get you to the 86 mark. So that means that there's a standard deviation of 7. Number 6, the scores on an exam have a normal distribution. The mean of the scores is a 50. The standard deviation is 4. What is the best approximation for the percentage of students who are expected to score between 46 and 54? Well, if we're looking at our standard bell curve, right here the peak is your mean, and they told us that that would be a 50. That was the average. They also told us that the standard deviation is 4. So if I take 4 off of 50, I would be at 46. So this would be at the 1 standard deviation below the mean. If I added that standard deviation of 4 onto the mean, which is 50, I would have 54. So that would be 1 standard deviation above the mean. So I'm looking at the data in this 68% of the data is going to be in that area. And then number 7. On a standardized test, the mean is 48 and the standard deviation is 4. Approximately what percentage of the scores will fall in the range of 36 to 60? First, I'm going to draw a basic normal distribution. That peak is going to be 48 since that's the mean. And I'm told that the standard deviation is 4. So 1 standard deviation below the mean would be a 44. And 2 standard deviations below the mean would be 40. And then if I go further, I'll take off 4 more for another standard deviation, so that would be at the 36 mark. And that would be 3 standard deviations below the mean. If I look above the mean, that value is greater. If I go 1 standard deviation above the mean, I would add 4 on, since each standard deviation is 4, and that would be a 52. If I added another standard deviation onto that, it would be 56. And if I added a 3rd standard deviation above the mean, it would be at the 60 mark. And you're noticing how each of these is 4 apart, since we were told that the standard deviation is 4. So if we're looking from 36 to 60, we're looking at a very large range here. We're not looking at 1 standard deviation within the mean. We're also not looking at 2 standard deviations within the mean. We're looking at 3 standard deviations within the mean. This would be 68%. 1 standard deviation above and below the mean would account for 68%. 2 standard deviations above and below the mean would account for 95% of the data. And if we're looking at 3 standard deviations within the mean, that would be this 98%.